Today I'll be talking about RTC DS3231. This is I2C real-time clock. Okay, so I'm connecting now pins, that is ground, VCC, and then I'll be connecting SDA and SCL. So orange wire goes in SCL, that is serial clock, and SDA, serial data. I'll be using my I2C LCD. Again, this will be using same for connections. So I'll be connecting it with my clock, ground, VCC, SD and SCL. So here goes ground, VCC, SDA and SCL. Next is the connections for RTC and LCD are made. Now I'll be using my Arduino Uno. So here I have this Arduino Uno. These two pins will be used, SCL and SDA. This goes in SCL, orange wire. This brown wire goes in SDA of Arduino. Now I'll be connecting ground and VCC. VCC will be 5 volts. So this goes in 5 volts and this one will be connected with ground. So here I have this connected with ground. In this video I'll be showing you how to change data with serial input of clock and how to change data using button. I'll be using single button control for this project, and last part of this video will contain alarm. So I'll be setting multiple alarms for this clock. So right now I'm connecting this button, but I'll not be using it until the last part of my video. So this is a long video, unlike other videos of mine. So this is going to go in pin number 8 of my Arduino. And another pin will be connected with ground. So here I've connected it with ground, and now that resistor of around 1.2k or 1 kilo ohms resistor, that is a pull-up resistor for pin number 8. So I'll be connecting it with 5 volts VCC. So here I've made the connections. All the codes that are used in this video are shared on my blog, so link of that blog is given in description of this video, and I have given the basic not the basic one, but the last code, the final code, final program, but I'll be discussing that program in parts. First serial input, then with LCD, then button, and then last part of that program will be alarm, setting up alarm. Now I'll be discussing code from a serial input. So I'll be using library wire.h for I2C and serial begin baud rate 9600. So I have some variables, some of which are going to be used with LCD and other for function of display on serial monitor. So here I have this function DS3231 display. First part of this function is that I'm converting BCD to decimal. Actually the values that I'm receiving from RTC are in BCD, so I have to convert them to decimal. So first part is that I am shifting first four higher order bit towards right and multiplied by 10, and the last four lowest order bit ended with 4 ones and then add it to the 10th of the values. So that is how I get decimal equivalent. So to convert them to the ASCII equivalent, I am using this particular time values, that is minute, hour, seconds. I'll have to use it twice, once for the 10, first for tens value and then for the unit value to convert them to the ASCII equivalent. Then I have this, my main function loop. So here I have this, if serial is available, then I'll go to read the serial input, which is my BS serial dot read. If BS equals to E for edit, so then it will be asking for inputs like hour, minute, date, month and year. So if it enters into the cycle of asking for R, it will check for R until the value has been given to it. So that is why I'm using this while loop, while x equals to 0. So when the value has been inserted, x will not be equal to 0 and while loop will end, and then it will place the R value in previous and R will be changed to x. So previous value is required if R value has been changed wrongly, like greater than 23. So then it will restore the value to the previous value which was given to it. All of this part of this particular function loop contains the same thing for each variable of time, which is hour, minute and date, month and so on. Here I am converting decimal to BCD because I wanted to transmit this data to my RTC, and RTC understands data which is BCD. So I'm doing the opposite of what I've done before when I wanted to display data on my LCD. So here I have this function BS equals to E and so on. So this I was using for testing purpose, so I'm commenting it right now. Then first part 0x68, this is the address for my clock, and then I am transmitting data, and I am transmitting data as minute, hour, day, date, month, year, and then transmission has been ended, and then delay of 300 milliseconds. So I'm not using day, but still I'm writing it. If I do not write day, so the values that are after the day are getting the garbage values, are getting unexpected results, like for month and year, and for date I was getting unexpected values. So I'm writing day. So what I determined from that is that values are being transmitted in regular order in consecutive order, one after another, so I have to mention day even if I am not using it. Okay, so, and here I have this y equals to 5. So actually y was done y equals to y plus 1 in the beginning of this function, and now when y equals to 5, so I'll be printing that particular line to edit e, so to keep the track of it, or to be as a reminder that you have to use e to change the value. And last part, I am printing it. Now the serial input code testing. I'll be testing this code, so uploading it on my Arduino Uno. And here I have this, it's displaying me time, okay, 23, 38, 5, 4, 23. So we'll be editing it, we'll use e and then we'll edit it this time. So now I am here, so I have provided the serial value, that is e, so that I enter the edit mode. So hours I have set 20 minutes 10, date 1 month 2, and year 20. And we have successfully changed the time to 20, 10, 1, 2 and 20. Next I will be showing the code for printing the time on LCD and the code for edit button, which is on pin number 8 that I have added. So I'm using liquid crystal I2C.h library, and then I see LCD initialization and LCD backlight on, and pin number 8 as input. Here I have those variables that I'm going to use to print on LCD, which is actually time and calendar. So again, that function of ours, and in that function I have added these LCD command to print time and calendar on LCD. Here I have this edit button. This is another function that is added to our code. So it is got LCD clear and instruction 1 and 2. We'll be seeing it shortly. Okay. So this function is actually called from loop function in our main program. Okay, so we have to go down it. So here it is, our loop. So if pin number 8 is 0, so here we are calling that function edit button. So here we have this instruction 1, that is leave button, and instruction 2, that is press button. So we are going to use these two instructions. So if digital 8 equals to 0, this means that we have pressed the button and 8 is 0. So r is going to be 0, and then we are going to add r's, r equals to r plus 1, and this will happen until we release the button again and digital read goes to 1. If r is greater than 23, we are going to set r to 0 and clear the LCD, and then printing those values on LCD. Instruction 1, that is leave button. So actually this instruction leave button is asking user to leave the button to set the value which is being seen on the LCD for R. Then once the button is left, digital read date goes to 1, and now you are in the minute section. Now minutes are adding up until you leave the button, until you press the button again. Once you press the button again and digital read date goes to 0, now you go to date part of the program, and now date is being selected. Okay, so again, instruction number 2. Instruction 2 is asking to press the button. So once the button is pressed, minutes are set for the day, for that particular time. Then date. So it is happening in a fashion that you have to press the button for hour, leave the button for minutes, and then press the button for date and leave the button for a month, and then press the button for year and leave it to select the particular value. This is how we are using, this is how I am using this single button control. So here is the year. So we are keeping it pressed, and once we release it, we are setting the value for year, and all the values are printed. So here I have this function, and date -1 I'm doing because I was getting +1 value, again converting it to decimal and then transmitting it onto our RTC clock. This part of the function is same as that of the previous one, which we have seen for serial input. So actually, as I've mentioned earlier, I'll be adding code to the same program again and again, and changing that particular program. Okay, so now we have seen the code, and now we'll be testing this code, and we'll be checking that whether this code changes time on LCD using a serial monitor. So firstly, I'll be entering time using serial monitor, and then I'll check it using button on pin number 8. So here I have this, I'm entering time, and it's going to be 5, 20, and so on. I'm entering the values, and these values should be put into effect on LCD if this code is working fine, and then we should see that those values are being changed on LCD as well. And here we have the values on LCD are changed as they are changed on our serial monitor as well. So changing it again, changing the time to current values, that is R equals to 16, minute 42, date 8, month 4, and year 23. We are inputting time using serial monitor, and that time is changing on LCD. Now we'll be checking that button. So I'll be setting time using this button. Currently time is this, and now I'm pressing the button. So hours, I'm going to set it on 16. So I'm pressing the button right now. When I leave the button, it will be set. So it says press the button. So when I press the button, minutes will be set. So right now minutes are counting up. So I'll be pressing this button when it reaches my desired value. So it's going to be on 35. Now it says leave button. Press, and now again for here it says leave button. So right now I'm pressing the button, and on my desired value of year I'll be leaving this button to set that particular year value. And here we have changed date and time successfully using our button. So now after this, we'll be connecting alarm, that is buzzer, with it, and we'll be seeing code of that alarm. So I'm connecting alarm, that is this buzzer, with it for uh, sounding alarm. So white wire is going to go in ground, and gray wire will go in pin number 9. I'm connecting this with pin number 9. Apart from using buzzer, we could do different controls. We could use different controls with this RTC. Like for example, if you want to water plants automatically, or you wanted to supply feed for your birds or something on some particular time, you could use this RTC, and when the time comes it will trigger motor or something, and it will actuator maybe, and it will allow water or feed to move towards the particular destination where we want it to. So this alarm is connected now. Now the alarm code. So here we have this edit button. In edit button we are actually including code for alarm. So here I have this for loop. This for loop enables us to set multiple alarms. So we are setting at least 2 alarms now. So here is this code for loop, and in for loop we have this alarm. This for loop allows user to at least have time to press the button and set the alarm. So if alarm equals to 0, it will ask user to set alarm number 1. So this function is now going to return alarm parameter to another main function of ours. And here we have this variables. So we have this condition: if digital read 0 and alarm is less than 2 or k equals to 2, it will set the alarm, and h alarm, m, and so on. These particular arrays are used to hold the values that we are going to set for our alarm, and as we want to set multiple alarms, so that is why I'm using arrays instead of simple byte or integer values. Okay, we could also use integer values as well. So now I have this array, and in array I have this indexing with alarm. So when the alarm changes its value, it is going to go on to the next value for array. Okay, and alarm equals to alarm plus 1. This is to show that alarm is set and the number of alarm. Now if alarm equals to 1, then we'll ask user to enter alarm number 2. If the user holds on to the button, it will allow user to enter alarm number 2. And it does k equals to k plus 1. Actually k plus 1 is for the for loop, which allows us to re-enter all the values for our second alarm. Now this is if alarm is set, if alarm is not equals to 0, then we'll return on to our previous values from where we have determined to set the alarm. Actually we'll return to those values of date and time. So here we have this variable al. It contains alarm, and if that al equals to 0, we'll have set date and time. And here we have this for alarm sounding, for turning on alarm. So it contains for loop, and it will check the integer values, array values, against date, hour, and minutes, and if it is found that these values are matched, our alarm will start sounding, it will go on. So the for loop actually allows us to check for both the alarms, alarm number 1 and alarm number 2, and compare its values with it. Now we'll be setting our alarm. We'll be setting both the alarms, alarm number 1 and alarm number 2. So the procedure is same. I'm setting all the values to 2, and now I'll be holding this button. So alarm 1 is set now. Now I wanted to set alarm number 2, and I'll hold on the button. So I'm setting all the values now to 4. Now alarm 2 is also set. Now I'll be using serial monitor to enter values for alarm and check them. Now I'm changing values and our alarm is set now. Now I'm changing values to some another value, let's say 5. Switch on to alarm number 2, that is 4. Now now I am setting date and time, so to make sure that that particular function is working correctly, if I wanted to set time and date. So we'll not be touching alarm now. When it asks asks us to hold button to set alarm, we'll be leaving that button. So the disadvantage of using a single button control is that I'm finding it very difficult as it is consuming a lot of time. So now we'll not be pressing any button. It is asking us to hold on the button, to press the button, but we are not going to, and it is going to display these values 5 times, display this message 5 times, and on 4 it returns to the set value. So this is the value that we have set.